What's the role of simulation in reinforcement learning, deep reinforcement learning, reinforcement learning? Like, how essential is it? It's been essential for the breakthroughs so far, for some interesting breakthroughs. Do you think it's a crutch that we rely on? I mean, again, this connects to our off policy discussion, but do you think we can ever get rid of simulation, or do you think simulation will actually take over? We'll create more and more realistic simulations that will allow us to solve actual real world problems, like transfer the models we learn in simulation to real world
Yeah.
problems.
I think that simulation is a very pragmatic tool that we can use to get a lot of useful stuff to work right now. But I think that in the long run, we will need to build machines that can learn from real data, because that's the only way that we'll get them to improve perpetually. Because if we can't have our machines learn from real data, if they have to rely on simulated data, eventually the simulator becomes the bottleneck. In fact, this is a general thing. If your machine has any bottleneck that is built by humans and that doesn't improve from data, it will eventually be the thing that holds it back. And if you're entirely reliant on your simulator, that'll be the bottleneck. If you're entirely reliant on a manually designed controller, that's going to be the bottleneck. So simulation is very useful. It's very pragmatic, but it's not a substitute for being able to utilize real experience. And this is, by the way, this is something that I think is quite relevant now, especially in the context of some of the things we've discussed, because some of these kind of scaffolding issues that I mentioned, things like the broken dishes and the unknown reward function, like these are not problems that you would ever stumble on when working in a purely simulated kind of environment. But they become very apparent when we try to actually run these things in the real world.
To throw a brief wrench into our discussion, let me ask: do you think we're living in a simulation?
Oh, I have no idea.
Do you think that's a useful thing to even think about the sort of the fundamental physics nature of reality, or another perspective? The reason I think the simulation hypothesis is interesting is to think about how difficult is it to create sort of a virtual reality game type situation that will be sufficiently convincing to us humans, or sufficiently enjoyable that we wouldn't want to leave. I mean, that's actually a practical engineering challenge. And I personally really enjoy virtual reality, but it's quite far away. But I kind of think about what would it take for me to want to spend more time in virtual reality versus the real world. And that's a sort of a nice, clean question, because at that point, we've reached, if I want to live in a virtual reality, that means we're just a few years away where a majority of the population lives in a virtual reality. And that's how we create the simulation, right? You don't need to actually simulate the quantum gravity and just every aspect of the universe. And that's that's an interesting question for reinforcement learning too, because if we want to make sufficiently realistic simulations, that may it blend the difference between sort of the real world and the simulation, thereby just some of the things we've been talking about, kind of the problems go away if we can create actually interesting, rich simulations.
It's an interesting question, and it actually, I think your question casts your previous question in a very interesting light.
Yeah.
Because in some ways, asking whether we can, well, the more kind of practical version of it is like, can we build simulators that are good enough to train essentially AI systems that will work in the world? And it's kind of interesting to think about this, about what this implies. If true, it kind of implies that it's easier to create the universe than it is to create a brain. And that seems like, put this way, it seems kind of weird.
The aspect of the simulation most interesting to me is the simulation of other humans. That seems to be a complexity that makes the robotics problem harder. Now, I don't know if every robotics person agrees with that notion. Just as a quick aside, what are your thoughts about when the human enters the picture of the robotics problem? How does that change the reinforcement learning problem, the learning problem in general?
Yeah, I think it's a kind of a complex question. And I guess my hope for a while had been that if we build these robotic learning systems that are multitask, that utilize lots of prior data, and that learn from their own experience, the bit where they have to interact with people will be perhaps handled in much the same way as all the other bits. So if they have prior experience of interacting with people and they can learn from their own experience of interacting with people for this new task, maybe that'll be enough. Now, of course, if it's not enough, there are many other things we can do, and there's quite a bit of research in that area. But I think it's worth a shot to see whether the multi-agent interaction, the ability to understand that other beings in the world have their own goals, intentions, and thoughts, and so on, whether that kind of understanding can emerge automatically from simply learning to do things with and maximize utility.
That information arises from the data.